Jing'an Temple Station is a key node on Shanghai Metro Line 14. It is located at the heart of the business and cultural district around the 1,000-year-old Jing'an Temple. Extended along Huashan Road and crossing Yang'an Road, the station is a 3-story underground structure with a dimension of 230 meters length by 21 meters width by 26 meters depth. The station served as a 3-line interchange hub with Line 2 and Line 7, with an estimated passenger flow of up to 400,000 people per day. The station is constructed in a soft stratum with low bearing capacity and high sensitivity. The surrounding urban area is highly diverse, with modern skyscrapers juxtaposed against historic Shikumen buildings and overpass. The station crosses underneath Yang'an Road, which is the only urban expressway in Shanghai that runs along the east-west direction through the city center. Consisting of a 6-lane viaduct and 14-lane surface road in both directions. Yang'an Road has an average daily traffic flow of 300,000 vehicles and serves for 45 bus routes. There are 54 municipal pipelines underneath the road, providing water, electricity, gas, and other supplies for 3 million residents. The section crossing underneath Yang'an Road is the key component of the project. The project is led by Shanghai Shantung Metro Group Company Limited, with the participation of the design company, construction company, and Shanghai Key Laboratory of Rail Infrastructure Durability and System Safety in Tongji University. By comprehensively comparing the feasibility of various undercutting methods, including the mining method, pipe-roof method, shield method, and pipe jacking method, this project proposed a new construction strategy that utilizes a multi-pipe jacking method, MPJM, to cross Jing'an Road. A series of novel structure design, construction equipment and technologies, and management was proposed, thus minimizing the influence of tunnel construction on ground traffic, adjacent pipelines, and buildings. As a result, a new construction method for a complex of city core metro stations restricted from open excavation was developed. In this layout, the station was constructed in 3 sections. 2 side sections were constructed using the cut and cover method. The section below Yang'an Road 82 meters was constructed by lower 2 parallel pipe jacking tunnels, PJTs, of 9.9 meters width by 8.7 meters height for the platform, and 1 upper PJT of 9.5 meters width by 4.9 meters height for the station hull. The depth of the upper tunnel is only 4.6 meters, while the clear distances between the 2 parallel tunnels and the overlapping tunnels are 2 meters and 5.4 meters respectively. The minimum distance from the tunnel to the municipal pipeline is 1.2 meters. In addition, the clear distance to the pile foundation of the viaducts of Yang'an Road on the 2 sides is 6.3 meters and 5.3 meters respectively. This project was the first application of the MPJM to build a large-scale underground station. In this project, 2 parallel large cross-section PJTs served as the side platforms in the lower parts, while a quasi-rectangular large cross-section PJT was adopted as the upper station hull. It increased the degree of mechanization in the construction of underground stations and provided a new construction method for city core metro stations crossing heavy traffic arterial. This project was the first application of overlapping large cross-section tunnels in a soft soil stratum constructed by pipe jacking method. Through optimizing the design for the outline and cutter heads of the pipe jacking machine, full section cutting of soils on the excavation surface was realized. A construction control cloud platform was established to perform real-time collection and correlation analysis of construction parameters, thus achieving optimized control for the construction process. This project also developed a whole process information management platform, providing prompt instructions and effective coordination through this platform. As a result, the efficiency of project management was improved while the cost was reduced. This project designed and implemented a novel type of steel-concrete composite jacking tunnel ring. An open grid-shaped Rebel steel tunnel ring was developed first. After assembled on-site by bolting, high-performance self-compacting concrete was poured through the opening, resulting in a steel-concrete composite structure. This new composite structure has sufficient stiffness, excellent seismic resistance, and waterproof performances. It also eliminated some common issues of large-span, reinforced concrete structures in the soft soil stratum, such as cracking on its outer surface and longitudinal uneven settlement. This project also had other achievements in terms of construction environment improvement and social responsibility. Dust-free techniques, including prefabricated segments, assembling by mechanical hosting, and silent tunneling were used in this project. In addition, instead of traditional walls, green barriers were used to separate the construction site and the surroundings. The vegetation buffered the construction site and significantly improved the environment. Structural health information was incorporated into the information management platform to achieve the whole life cycle maintenance of infrastructures. The proposed design methods, construction equipment and technologies, and digital management can be not only applied in the future projects, also worth popularizing in other cities. A science popularization base was established to alleviate the public concerns about construction safety. A VR virtual reality system was established to provide the general public with experience and popular science knowledge about the construction of stations and pipe jacking tunnels. The project team established a co-construction work group that integrates with the local community to overcome problems of construction disturbance. The project team informed the construction progress plan with the local community in advance through the co-construction work group. The construction operation plan can be adjusted in real time based on the feedback. As a result, there were no complaints from residents during the entire construction period. The science popularization base and a VR virtual reality system developed in this project has been extended to Shanghai Metro Museum, Shanghai Metro Science Popularization Base, and Shanghai Key Laboratory of Rail Infrastructure Durability and System Safety. They have become an important part of the social and cultural construction of Shanghai Metro. In 2021 alone, the VR virtual reality system received 45,018 social audiences, including more than 2,500 students from 6 primary schools and 8 middle schools in Shanghai. A diversified financing model was established to reduce the pressure on construction funds. The construction of the PJTs took a total of 25 months, with an average of 150 workers per month and a total of approximately 1.72 million man-hours. The construction of the PJTs for the platforms of the East and West lines was carried out simultaneously, with approximately 200 workers during the peak construction activity. There were no accidents and casualties during the entire construction period. Moreover, the working status of the hydraulic cylinders was monitored. Any leakage faults were diagnosed every 30 minutes using subspace identification method based on recorded operation data. There was no hydraulic cylinder leakage. The tunneling parameters were monitored and remotely managed by using the information management platform. The counterheads were in normal state during the entire construction period. The maximum measured settlement and horizontal displacement of the bridge cap were 3.7 millimeters and 5 millimeters. Furthermore, the influence to ground traffic on Jing'an Road and municipal pipelines was minimized during the construction period of 50 months. The Jing'an Temple Station was the first metro station in China built using the multiple pipe jacking method. The project was also the first in worldwide engineering records to build vertically overlapping, double-deck large cross-section tunnels in the soft soil stratum by path jacking method. This project formed a new construction method for a complex of city core metro stations restricted from open excavation. It increased the degree of mechanization in the construction of underground stations and provided a new solution for the safe, green, and efficient development of deep underground space in urban dense areas.